Okay, so in my previous video, I have discussed about the term amplifier and the different classification of amplifier depending on the basis of the work it is doing and depending on the position of Q point. Now, different types of amplifiers such as voltage amplifier, power amplifier, current amplifier, class A, class B, class AB, class C, and direct couple amplifier I have discussed already in my previous video. So in this lecture I am going to discuss about the multistage amplifier and why it is necessary to use a multistage amplifier and the different multistage amplifier used with the help of coupling method, and we are interested to deal with the new term cascading. What is cascading? We are interested to deal with it. So without wasting any time, I am going to discuss. So multi-stage amplifier. Very often the voltage or current gain obtainable from a single stage amplifier becomes insufficient for our practical use. So, as because the single stage amplifier do not produce the necessary or required voltage amplification or current amplification or whatever we are interested, so a double stage amplifier is formed by the cascading method. Now what is cascading method? When a single stage amplifier, the output of a single stage amplifier is again used as the input of the next stage of amplifier circuit, then it is taken to be as the multi-stage amplifier, and the method of producing it is known as the cascading. So the amplifier is also known as to be the cascaded amplifier. Okay, in this case the overall voltage gain, if we use the input voltage 1 being Vi1 and the output voltage be represented by VO1, this VO1 is again used as the input of the next stage, so if the input of the next stage be Vi2 and the output of the next stage be VO2, then from our principle of multistage amplifier we know that VO1 is nothing but equal to Vi2, and the overall voltage gain becomes the output of the second stage divided by the input of the first stage, Vi1. This is again to be simplified by VO2 by Vi2 into Vi2 divided by Vi1. Now Vi2 is again equal to VO1, that is VO2 divided by Vi2 into VO1 divided by Vi1. So overall voltage gain is nothing but the product of the voltage gain of the two stages separately. So AB1 into AB2. So this is the overall voltage gain of the multi-stage amplifier. Here I have deal with two-stage amplifier. So for two-stage amplifier, the total or overall amplification of the voltage is nothing but the product of the two-stage voltage amplification. Now in the voltage amplification, the C mode of the transistor is used mainly. Why? Because the voltage gain of CC configuration, that is the common collector configuration of the transistor, is not suitable for cascading since the voltage gain is less than unity. Similarly, for CB mode, the voltage gain of intermediate stage of cascading is the current gain of the stage times the effective load resistance divided by the effective input resistance. As the current gain of the CB stage also is insufficient or less than 1, the voltage gain is also less than 1 in the cascade. So the CB mode is also not used. Hence, the C mode of the transistor is mainly used in case of cascading. Now, another term lies which is known as the impedance matching. Because of the impedance matching, because of the same order of impedances or same order of the resistances used in the CE mode, that is RB and RC are of the same order. So, C transistor mainly used in the cascading. Now we have to define the network. Network is what? Network is nothing but the circuit that couples the output signal of the first stage to the input of the next stage of the multi-stage amplifier. So as because the first stage amplifier couples with the second stage amplifier, this network is also known as the coupling network. So I have defined the term coupling network. Now, depending on different elements used in the coupling method, coupling amplifier can also be classified into many classes, like RC coupled amplifier, in which the resistance and capacitance are used as the coupling element. Again, the transformer, if we use the transformer as a coupling element, then it will be said as to be the transformer coupling amplifier. Now, what is RC coupled transistor amplifier? Carefully notice it. The circuit diagram is very important. Here we use two C mode transistor in voltage divider or self bias mode. This is the load resistance RL. This is the VCC power supply. This is C capacitance, input capacitance. This is coupling capacitance, as because it always make a barrier to the DC part. It will block the DC part and allow the AC part only as the input signal. So it may be the first stage or maybe the intermediate stage. So we write here from previous stage or source. From previous stage or source. And this is the another terminal. This is R2 resistance. This is R1 resistance. This is RE resistance, and this is the bypass capacitor, and this port is grounded. This is the coupling capacitor. This will couple the first stage with the second stage. So this is the circuit diagram of the RC coupled two-stage amplifier, in which the first stage of the transistor is coupled with by the coupling capacitor CC with the next stage transistor. So all the two stages are identical. Now if we divide it, the left portion of the circuit is taken to be as the first stage, and the right portion of the circuit is taken to be the second stage of the RC coupled amplifier. Now I have to define the construction. So the constructional details is nothing but here we use the two-stage RC coupled transistor amplifier circuit. The amplifier circuit has two transistors which is taken to be in CE mode, and common power supply VCC is applied, and the voltage divider network is formed by the resistor R1 and R2 and RE. This is also RE. So these are two RE resistance. This is the bypass capacitor. Okay, this is also bypass capacitor. Okay, so these form the fixed bias network. Hey, sorry. So the self bias network or voltage divider network, which confirms the stabilization of the network. Now RL is used as the load impedance, the capacitor C in present in the initial stage of the amplifier couples the AC signal to the base, and the capacitor CC couples the first stage output to the next stage as the input. So this is the RC coupled amplifier. Operation of the RC coupled amplifier is nothing when the AC input signal is applied to the base of the first stage of the transistor, it gets amplified and appears at the collector load RL, which is then passed to the coupling capacitor CC in the next stage. This becomes the input of the next stage, whose amplified output again appears across the collector load. Thus the signal gets amplified stage by stage action. Here lies the importance, and it is taken to be the important point that has to be noted here, that the total gain is less than the product of the gains of the individual stages. This is because when the second stage is used to follow the first stage, the effective load resistance of the first stage is reduced due to shunting effect of the input resistance of the second stage. Hence, in a multi-stage amplifier, only the gain of the last stage remains unchanged. This should be kept in mind. Now, I will discuss about the term frequency response. Now, uh, the voltage amplification factor AV is defined as V2 by V1. This is also represented by the magnitude and the phase angle. If the magnitude be represented by the modulus of AV and the phase angle be represented by del theta, sorry, the angle of theta, then the voltage amplification factor may be defined as this. Now the variation of magnitude and phase angle of the gain of the amplifier with the frequency is referred to as the frequency response curve. Very important. If we plot, sorry, if we plot along y-axis the magnitude of voltage amplification and along x-axis we represent the frequency, then we will obtain a result like this, in which the mid frequency range where the magnitude of the voltage amplification remain constant but the phase angle is at 180 degree is known as the mid frequency gain. And in case of low frequency range, the magnitude of AB decreases and the phase angle increases over 180 degree below the mid frequency range. And in the higher frequency range, the magnitude of AB goes on decreasing with the decrease of the phase angle also. So if we plot the phase angle versus frequency, then we will end up with this type of graph. This is taken to be the 180 degree in which the frequency remains constant, or frequency, uh, the magnitude of the voltage amplification remains constant and it goes on increasing in the lower frequency range and goes on decreasing in the higher frequency range. So if we plot along x-axis frequency and along y-axis the phase angle, then this is 250 degree, 225 degree, and this is to be 270 degree, this is 135 degree, and this is 90 degree. Okay, so this is the mid frequency range. Now here an important point lies that at the frequency where the magnitude of the voltage amplification becomes the half of the maximum voltage amplify or the peak of the voltage amplification, then it is known as the half power frequency in the lower range, and also it is obtained at the higher frequency range. This is represented by fh. So the bandwidth can also be obtained by the help of this difference in frequency. Okay, so I have discussed the frequency response curve and the circuit diagram of RC couple amplifier and the cascading term and the multi-stage amplifier. So in this lecture uh, I will not discuss anything about it. In my next lecture I will describe in detail what is the mathematical expression behind this. Thanks for watching.